Okay, this question 7, and these are rather difficult question, but don't worry, I bring you through, and you'll see how it can be done. A boy 1 meter tall stands in front of a large mirror, which is over here, as shown below. Okay, draw rays to show how he can see his head and his toe. So his toes are over here. His head, top of the head is over here. Eyes is over here. What is the minimum height of the mirror required for him to see his whole body? Okay, so this is the mirror, and this boy wants to know what is the minimum height of the mirror. Okay, I think he don't want to buy such a big mirror, so he want to know what is the minimum height of the mirror. Okay, which can be used to see his whole body. Okay, so how do we go about doing this question? Okay, for this question, the first thing you have to do is to locate the toes and to locate the top of his head and the eyes. Okay, the eyes is where he actually receive the reflected rays from the toe. Okay, so the first ray that I draw is from the toe, okay, hitting the mirror and to his eyes. So the second ray that I'll be drawing, it will be from the top of his head. Okay, light rays coming from the top of his head, hitting the mirror and coming to his eyes. Okay, only when the light rays comes to his eyes, then he can see the top of his head and the toes. Okay, so over here, how to find the minimum height? Okay, first, okay, you label the distance from the toe to the point where it hits the mirror as y. Okay, so you label this as y. Just put any alphabet. It can be y, can be z, can be a or b. So over here, the solution, just put it as y. And over here, between the reflected ray and the eye level is also y. Okay, why is this so? Because the incident ray and the reflected ray both travels the same distance. Okay, so this is true for the ray from the head, okay, to the eyes, but we label this as x and x. Okay, so over here we know that 2x plus 2y equals to 1. Okay, so over here I will first write down the equation. Okay, I will first write down the equation. Okay, 2x plus 2y equals to 1 meter. So you see, x plus x, y plus y will give you the height of the boy. And let's pull out the common factor over here, which is 2. And then x plus y equals to 1 over 2, which is equals to 0.5 meters. So this is the answer over here. X plus y is 0.5 meters. So the minimum length of the mirror that the boy can use in order to find his own body length is actually 0.5 meters. Now for question 8, P and Q, okay, P and Q are 2 points on the ground, are illuminated by a source of light as shown below. Before the mirror is placed, okay, the intensities of light at P and Q are the same. Okay, after the mirror is placed, point P is brighter than point Q. Explain by drawing the reflected rays from the mirror. Okay, so what is meant by this? And okay, what is meant by this? Okay, I'm going to draw it out. Initially the mirror is not there, so there's only the light source. Okay, so there's only the light source. Okay, it says that intensities of light at P and Q are the same initially. Why is this so? Okay, this is because the light from the light source actually reach P and it also reach Q. Okay, it reach both P and Q at equal intensity. Okay, so why is it that after placing the mirror, P will be brighter than Q? Okay, so I'm going to explain to you why. Okay, now the light source. Okay, when the light is coming out from the light source, it actually got reflected by the plane mirror and it reaches this area. Okay, but look carefully over here. The plane mirror is only this length. Okay, and light can only be reflected, okay, maximum at this point, because if light travels any further, okay, they cannot travel any further. Okay, look over here. Light can actually bounce here, come down. It can also bounce here and it comes down. Okay, and it can also bounce here and it goes all the way down here. Okay, and it can also come to the edge of the plane mirror and comes here. Okay, but then any light that comes here, okay, will be lost. Okay, see, the light coming out from here will be lost. Okay, and therefore, okay, as we can know, as we can see over here, so the reflected rays are all concentrated, okay, over here at this portion. All right, so why is it that P is brighter? Is because now the light, okay, other than coming from directly from the light source, it also receives light, okay, by the reflection of the mirror. As compared to Q, Q only receives light from the light source. Okay, because all the light coming, okay, towards this direction is lost. It cannot be reflected because the mirror is only so short. Right? So Q is illuminated by the direct light source only, while P is illuminated both by the direct light source and the reflected light from the mirror. In question 9, okay, the question says that the diagram below shows two light rays from an object P incident on a plane mirror M. This is the object P and this is the mirror M. Complete the diagram to show the path of the ray after reflection from M. Using the reflected rays, locate the position of the image P. Okay, so this one, okay, the question sounds a bit confusing, but don't worry. Okay, this question is actually very simple. Okay, so how do you go about doing it? Okay, so we know that this is the incident ray. Okay, so the first method that you can use is actually to measure the angle over here. Okay, and from this angle you will know the angle of incidence, and therefore you know the angle of reflection. Okay, so there's another normal over here. So you can use your protractor to actually measure them, and you can find the angle of reflection, and you can draw in the reflected rays, and from the reflected rays you can actually extend the line and you can find the image P. Okay, so that is the first method, and is a bit more troublesome. So I'm going to show you a shortcut. Okay, what's a shortcut over here? The shortcut is simply, okay, to follow, okay, the PowerPoint slides method which I've given you. Okay, first locate the object. The object is P, and we draw in the image first. How do we draw in the image? Okay, so the image is actually perpendicular, okay, to the mirror. So this one over here is 90 degree. So you actually draw a line, and then you locate the image P. Okay, remember that both these distances must be the same. After you have drawn in the image, okay, you can actually extend the line, joining, okay, extending the line and joining the point where the incident ray hits the mirror. Okay, so after extending, you can draw in the reflected ray. Okay, this method you do not have to use any kind of protractor. Okay, all you have to know, okay, is the image, the distance, okay, of the object from the mirror, and then you draw in the image, and then you join, okay, the rays to where the incident ray hits the mirror.